Questions 21 to 25 on the 2009 Grade 10 AMC 10A. Many Gothic cathedrals have windows with portions containing a ring of congruent circles that are circumscribed by a larger circle. In the figure shown, the number of small circles is 4. What is the ratio of the sum of the areas of the 4 smaller circles to the area of the larger circle? This is our diagram, and let's try to look at what possible scenario we can find in terms of a relationship between the radii of the 2 circles. And if you draw this type of a diagram where I'm just connecting the dots really, and those dots are the centers of the small circles, you'll notice that all of these are small r, all of those guys. And this one here, from here to here, represents the radius of the large circle. So from this triangle right here, I can get a relationship using Pythagoras. This side, of course, from here to here, is the large radius minus the small radius. And then very similarly, this is also going to be large r minus small r. And then the hypotenuse of that triangle is just 2r. And that r being the small r. So there you go. That's my relationship. And when this is all said and done, hopefully we'll be able to get a relationship between r. So here we go. We got some algebra to do. This is just going to be r minus r squared. And that's going to be 4r squared, but we're going to divide by 2r squared, because there was 2 of these guys. Now expand, and we get big R squared minus 2 big R small r plus small r squared is 2r squared. Put everything on one side. We get r squared minus 2rr minus r squared. And I don't think this factors nicely, so unfortunately I have to use a quadratic, but that's okay, shouldn't be too bad. Minus b plus or minus square root of b squared, which is minus 2r squared minus 4ac under the square root sign all over 2a. And that is equal to r. So simplifying, this becomes 2r plus or minus, that looks like 4r squared plus 4r squared, so 8r squared all over 2. And that means this is going to be 2r plus or minus 2 root 2r all over 2, and that is r plus or minus root 2r. And I can further sort of factor out the r and just get 1 plus root 2. The reason it can't be negative is because if I did negative, it would become a negative answer. So this is the only possible answer. All right, perfect. We got a relationship between small r and big R, and now we can calculate the ratio. They wanted me to figure out the ratio of the area of the 4 small circles, so that's going to be 4 pi small r squared, to the area of the big circle, which is pi big R squared. And I can do that. The first thing I notice is the pi's cancel, so I'm just left with 4r squared over r squared. And then I can substitute in my finding right there. So instead of big R, I can put small r, 1 plus root 2, all squared like that. And then the good news is the r's cancel, so we're just left with a numerical value of, if I expand that, it's going to be 1 plus 2 root 2 plus 2, and that is 4 over 3 plus 2 root 2. Yeah. And unfortunately, not that it's a big deal, but we have to rationalize the denominator. They don't like to leave radicals in the denominator, right? I don't know why. I've never understood why that rule exists, but no problem. We can multiply top and bottom by the conjugate to rationalize the denominator. And when you do, you get 12 minus 8 root 2, and the denominator becomes, let's see here, 9 minus 8. So that's good, that's just 1. So 12 minus 8 root 2. 12 minus 8 root 2 is the answer. Let's see here. 12 minus 8 root 2 is this one. I don't know why they factor it out the 4 there, but whatever. Number 21, the answer is C. 2 cubical dice each have removable numbers 1 through 6. The 12 numbers on the 2 dice are removed, put into a bag, then drawn one at a time and randomly reattached to the faces of the cubes, 1 number to each face. The dice are then rolled and the numbers on the 2 top faces are added. What is the probability that the sum is 7? As always, with every probability question, there's going to be a numerator and the denominator. The denominator in this case is the total. So the total number of ways of picking 2 numbers from 12 is 12 choose 2. Right? Because they are basically saying that they're going to draw top 2 faces. So you're really just choosing 2 numbers to figure out the sum, and then that sum has got to be 7. So we got the denominator. The numerator is our specific condition, and that is that the sum of those 2 numbers is 7. Okay? All right, so how do we get a sum of 7 with 2 numbers? First of all, what are the numbers? 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Those are the numbers, obviously, 2 dice. How do we get a sum of 7? Well, a sum of 7 can be obtained 1 plus 6, 2 plus 5, or 3 plus 4. Those are the only ways, right? So looking at these, how can I get that? I can have 1, let's see here, 6. I can have, I'm trying to use the colors here. I can have another 1 red, and then let's see here. This will be red, this will be red, and this will be blue. So you see what I did there? What are the possible ways I can get a sum of 7 using these 12 numbers here? So for each of these scenarios, I'll have 4. There's 4 scenarios. This will also give me 4 scenarios, and this will give me 4. So there's a total of 12 ways of getting a sum of 7 if you use these 12 numbers. And I just broke them up. Like this represents the first dice, dice number 1, and this represents the numbers on the second dice, dice number 2. And I just colored them red and blue just to show that they're different. So 12 is the possible ways of getting a sum of 7. So this is the probability. 12 choose 2 is 66. So 12 over 66, is that in lowest terms? No, it's not in lowest terms, right? Divide top and bottom by 6, I believe. So 2 divided by 2 over 11. So number 22, the answer is D. Convex quadrilateral ABCD has AB equal to 9, CD equal to 12. Diagonals AC and BD intersect at E. AC is equal to 14, and AED and BEC have equal areas. What is AE? Let's draw our diagram and try to understand this question. So we've got AB, and then not entirely sure what this looks like, but let's just work with this. All right, so here we go. A, B, C, D. And then they tell me that this is 9 and this is 12. And then they tell me that they're drawing this line AC. So all the way from there to there is AC. And another diagonal that is going from there to there. And they bisect at a point E. And then they tell me that these two triangles, AED and BEC have equal areas. Since that is true, that means that these two triangles must also have equal areas, ACD and BCD, because they share this triangle ECD. So let's write that here. That means that triangle ACD is equal to triangle BCD in terms of area. And the only way that is true is if the altitudes are the same. If you were to draw perpendicular lines from A to the bottom and B to the bottom, those two lines would have to be the same length because these two triangles share the same base. And the only way they can have equal area is if these two heights are the same. And that allows us to conclude that AB is parallel to CD. This line must be parallel to CD. And if that is true, which it is, then that means that triangle ABE, this triangle, is similar to triangle CDE, this triangle. So triangle ABE is similar to triangle CDE. And we can then use the ratio of the sides to get some relationships. So AE over AB, and this triangle ABE, is equal to EC over CD, and this triangle. So rearranging a little bit, we get AE over EC is equal to AB over CD, but we can just put in the numbers 9 and 12. And in lowest terms, that's 3 over 4. So that means that AE, which is right here, over EC is 3 over 4. So what I can do is I can label AE, say 3x, and I can call EC 4x, since they have a ratio of 3 to 4. So I'll call this 3x, and I call this 4x. But they tell me in the question that the full length AC is 14. So AC, they tell me, is 14. Now AC is equal to AE plus EC. And I've labeled it 3x plus 4x is 14. So that means 7x is equal to 14. And therefore x is equal to 2. So finally, to figure out the length of AE is equal to 3x, and therefore that is 3 times 2, which is 6. So number 23, the answer is E. 3 distinct vertices of a cube are chosen at random. What is the probability that the plane determined by these 3 vertices contains points inside the cube? So let's draw a cube. And let's just label these vertices 1 through 8. I think that should be sufficient to talk about this question. So again, another probability question. So it's going to be some numerator over a denominator. The denominator will be the total possible choices, and that's going to be 3 vertices, right? So for the first vertex, I have 8 possibilities. Then I have to choose distinct vertices, so I can't choose the same one. So only 7 possibilities remaining for the second choice. And for the third choice, 6. So that's my bottom number. Now I have to figure out the numerator, and that is my specific condition, which is that the plane determined by these 3 vertices contains points inside the cube. So what I'll do is just illustrate for one fixed value, and then we can extrapolate for all of them. So let's say my fixed value is 1, meaning that is going to be my first vertice. And then we'll talk about all the different possibilities that this is true, that the plane determined by these vertices contains points inside the cube. If my first vertex is 1, let me say my second vertex is 2. What can my third vertex be to satisfy the condition? Can it be 4? No, because that doesn't have any points inside the cube. How about 3? Nope, same thing. There's no points inside the cube. How about 6? Well, let's see. Again, nope, it doesn't. How about 5? Again, it doesn't. Now, I'm not going to go through this for every single one, but I just want to illustrate what this question is talking about. But what about 8? If you choose 8, then yes, this plane starts to contain points inside the cube. So 1, 2, 8. And similarly, 1, 2, 7. So these two, when 1 is fixed as the first vertice, will give you the required condition. Now I've exhausted the 2's. Now let's try 1 and then 3. And if you do, you will see that 1, 3, 6 and 1, 3, 8 satisfy the condition. And that's another 2. And you can use this diagram to kind of draw lines and figure this out. And you keep going like this, and you'll find that for 1, 4, it's 1, 4, 6, 1, 4, 5, 1, 4, 8, and 1, 4, 7. These will satisfy the condition. For 5, it's just 1, 5, 8, and 1, 5, 4. And then for 6, we have 1, 6, 4, 1, 6, 3, 1, 6, 8, and 1, 6, 7. Those will satisfy. And then for 7, we have another 4, 1, 7, 8, 1, 7, 6, 1, 7, 2, and 1, 7, 4. And finally for 8, we've got 6 of them. 1, 8, 2, 1, 8, 3, 1, 8, 4, 1, 8, 5, 1, 8, 6, and 1, 8, 7. So you add all these up, and when you do, you get a grand total of 24. Right? 6 plus 8 is 14. 14 plus 6, 20. 20 plus 4 is 24. But 24 is only for the 1s. You see? 1 was the only value that I fixed. So I can do the exact same thing for each of these 8 vertices, where the next scenario I can make, 2 as the fixed one, and then 3. So for each of those 8, I will get 24. So 8 times 24 is my numerator. So that's what goes up here. So there you go. That's the answer. Of course, we have to lower it to lowest terms. Let's see here. The 8's cancel. 24 divided by 6 is 4, so I just get left with 4 over 7. And therefore, number 24, the answer is C. For k greater than 0, let ik be 10 dot 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 0, 6, 4, where there are k zeros between the 1 and the 6. Let nk be the number of factors of 2 in the prime factorization of ik. What is the maximum value of nk? So, if you have any number and you divide by 2 and it ends in 64, there's a couple different scenarios. The first scenario is, let's just look at 64 itself. If you divide by 2, you get 32, then 16, then 8, then 4, then 2, then 1. So how many times was I able to divide by 2? 1, 2, 3, 4, 5, 6, right? And therefore 64 is equal to 2 to the power of 6. Now I can't keep going here, because if I divide 1 by 2, I get a decimal. And that's not allowed, because we can't do that with factors. So that means it looks like 6 is the only way, no matter what the number is. But there's one other scenario when you have very large numbers. And that is, you can have some big large number, let's say 1000064. And this number has a unique property as follows. If you take this number and start dividing by 2, you will get pretty much the same kind of story as this one. You get 32, you'll get 16. I'm just writing out the last 2 digits. You'll get 08, you'll get 04, and then you'll get 52. And interestingly, 52 is divisible by 2. 26 is what you get. You notice how we don't get a 1. And then what that allows me to do is go one more further into 13. So now I've got 1, 2, 3, 4, 5, 6, 7 times. So this number is 2 to the power of 7 times something. I think it's 2 to the power of 7 times 7813, I believe. So as you can see, this was the key right here. It allowed me to go one step further. Normally when you divide by 2, you get 1. But if you have something like 52, or if you had 12 and you divide by 2, you get a 6. And like I did here, and that 6 allows me to go one step further. And this is indeed the maximum, because there's no way that you can have anything more than 7 in terms of the number of factors of any number of this form, where you have 1 followed by a bunch of zeros and then 6, 4. So number 25, the answer is B.